Why are 3D point clouds so crucial in applications such as self-driving technology? It's simple. They provide the essential depth information that is lost when we capture photos in 2D due to a process called perspective projection. This is also the reason why distant objects appear smaller. It's also why parallel lines seem to converge towards a single point. This depth information plays a crucial role in accurately measuring the distance and size of various objects on the road, allowing autonomous vehicles to navigate safely and efficiently. Now, you might wonder, how do we extract this depth information? Well, one of the simplest methods is using a stereo camera layout. This layout mimics human binocular vision, with two cameras taking images shifted by a horizontal distance apart, similar to our left and right eyes. The stereo camera layout provides the necessary relationship between the three-dimensional world and two-dimensional coordinate systems. This relationship allows the estimation of depth information for the viewing scene. To achieve this, we need to understand the extrinsic and intrinsic parameters of the camera. Once the camera is calibrated, the next step is triangulation. This process uses the known positions and angles of the two cameras to estimate the location of points in the scene. Then comes the task of stereo matching, which involves finding disparities or differences between the two images. This is done using a technique called template matching. However, stereo matching presents its own set of challenges. For instance, the surfaces must have non-repetitive textures, and there may be differences in brightness or other features between the two images due to the foreshortening effect. But these challenges can be overcome by choosing the appropriate window size for template matching. Too small a window may be less descriptive and sensitive to noise, while a large window might produce a more robust but blurred disparity map. Therefore, an adaptive window solution is often the best approach. The final goal of 3D reconstruction is to generate a depth map, an image where every pixel contains depth information rather than color information. The accuracy of this depth map depends on the type of sensor used, with LiDAR, infrared, and cameras offering varying degrees of precision. Stereo reconstruction, the process we've discussed today, uses simple cameras to generate depth maps. It's the same principle our brain and eyes use to understand the depth of our surroundings. With a calibrated camera, the correct parameters, and some clever techniques for overcoming challenges, it's possible to generate accurate 3D point clouds for a variety of applications. So the next time you see an autonomous vehicle navigate smoothly on the road, or marvel at the precision of augmented reality, remember the crucial role of 3D point clouds and the power of stereo camera layouts in making these technological marvels possible. Each subscription not only means you get access to a wealth of knowledge, but it also supports our efforts in creating more such informative content. So why wait? Hit that subscribe button.